All right, here's the video with the 5 tangent skills. I'm going to go through this pretty quickly, but remember you can always pause it. The first skill is the question, is this segment AB? Change it to the circle. Okay, so if it's tangent, that means it creates a right angle. So basically on this, you are going to make sure you plug in these 3 numbers they give you on this triangle, and we're going to use Pythagorean theorem as our tool. And if they actually are equal, so if I square A and B and add them together, and if they're equal to 9.5 squared, remember the hypo is always across from the right angle. So what you'll do is you can put your A in, A squared, B squared, and see if they add up at equal to 9.5 squared. And in this one, they do. So if they do come out equal, it's a tangent, meaning yes, or it's not a right triangle, meaning A squared plus B squared does not equal C squared. Then it's a no, it's not tangent. So basically, this is just going to give you a couple different ways that they can present this information to you. Once again, this is another is AB tangent to the circle. That's basically testing if this is a right triangle. All right, so carefully here, when you get information presented this way, make sure you know that this is the entire hypotenuse. So you'll have to add those 2 numbers up. So you'll add 2.4 and 3.6, and the hypo is actually going to be 6. So if I labeled this A, I would need a B, A squared plus B squared. So I could put the 4.8 right here. The question is that we're not trying to find B. It already gave it to us. It just gave it to us in a weird way. So basically what you need to be able to do is that recognize what part of the circle this is. This is a radius right here, and no matter what, if that's a radius, any radius from the center of the circle will be the same distance. So every radius is 3.6. So now that's going to tell you that this 3.6 here will also be here. So this will be your B. Will be the 3.6 that will come down to here, and 4.8. So you'll take 4.8 squared plus 3.6 squared and see if it equals 6 squared. It's a equal, it's a yes or no. If it's yes, it's tangent. If not, then it's not tangent. The second skill is finding missing segments. So you got to recognize the segment that is hitting at the edge of the circle once, and recognize that is a right angle. And this is the hypo. So basically, you're not trying to find C, you're trying to find A or B. So if I was to label this A, this would have to be B, this whole side here. So I would put 8.4 squared, 8.4 squared. I would leave B a variable and then put 14 in for C and use Pythagorean theorem to find my missing side. So that's how you find missing segments with tangents. Of course, this looks nice and easy, but again, they're going to give you the data in a little bit of a different way. So here's a problem here, finding the missing segment. So I have to first recognize my right angle. It's never in the middle of the circle, it's on the edge. And this portion is my hypotenuse. Well, I only need a certain amount of it. Okay, moving on. Number 12. Okay, so this is another Pythagorean theorem. So what we'll do is make our right angle, recognize this as the C, recognize this whole thing as a B, and this down here is an A. Okay, I could mix up the A and B, of course. But, so what you're going to have to do here is if you find B, you'll have to recognize it as a diameter. So I've already done this, and you can do this with me if you want real quickly, but if I put 12 here and 20 here, I will end up with 16 after taking the square root. So this whole thing is 16. Notice it's not in your answers. You're going to have to cut it in half because the question mark wants this portion only. It wants the radius because that's half of this line that goes all the way through, and this line is the diameter. It's 16, so you would have to cut it into 2/8, and this guy's an 8, and that's where you find your answer. Perimeter with tangents. Okay, so we have a triangle outside of the circle here, so a circle inscribed in a triangle, basically, kind of thing here. So what you need to know is that these are not midpoints. You cannot make them midpoints. So they could be a midpoint. It's possible, but it's not the rule that these have to be cut in half. The rule is, or the process is to make isosceles triangles here. So this piece is what's going to be equal. So yeah, this 16 gets cut in half, but it's just a coincidence here. It doesn't mean it has to be a midpoint. So that's how you find the sides. You create little isosceles triangles on every corner. Okay, so on this green one, this has to be an 8 because this is cut, and this 16 is cut with that 8 and that 8. So this piece has to be an 8. So now, because this side is not 16, we now know that that's not a midpoint. So how would I get this is a simple little plus little equals big here. I got a 14 plus 1 minus 8, and I get a 6.1 here. So I would have to create another little isosceles triangle here, and then I could replicate this over here, and now each section is accounted for, and you just add them all up. Perimeter is add up all the outside edges. Okay, so how to find perimeter with a quadrilateral on the outside. Once again, my process is to recognize little triangles here. So this guy is 10.5 because it's going to be equal. All right, so then we have another one here with these two. So this is going to be a 6.3. And I'm just going around. So a 6.3 and a 20.3. So this piece down here has to be 14 because 14 plus 6.3 is 20. So what do I do with the 14 is I continue to work these isosceles triangles here. So if that's a 14, this is a 14, and then I use this 22.2 and get me 8.2 because 8.2 plus 14 is 22.2. And now I get to my last triangle, and these pieces have to be equal, and now I have every single section accounted for, and I would add up all the outside lines to get my answer. So you're making little triangles. These are not midpoints. All right, 21, this skill, finding missing angles when tangents are on your triangle. Okay, so what I recognize is I always recognize that I have a big right triangle always here because it's a tangent. Okay, so I have a right triangle, so I got 90, 51, and 39. Okay, so now where do I go from here? Is I'm going to go back, and I want you to know we got to be able to use this type of triangle. What I mean by that, what type of triangle it is that this is a radius, and all radii are going to be equal. So that means these two are equal, and this is an isosceles triangle, and these will be your congruent base angles. And If I do a half circle in here for a linear pair, I will get 39 plus something equals 180. Another type of example with a tangent is what I kind of see here is I want you to see, hopefully, is if I take a look at these two lines here and get rid of them, it's kind of like we have a kite in there, okay? So we have actually two lines that are tangent. So we got this guy and this guy, and when these tangents hit here, we will have two right angles. So really we have a kite with a 90, 90, and 62 in. So let's take 360 and subtract those three. So I'm going to take 360 minus the 290s and minus the 62, and I get 118. So there'll be a 118 up here. Okay, so what am I going to do with that? How does that get me this guy? As it goes back to the previous question, is you have to recognize what you have. These pieces here is a radius, and this is a radius, meaning this is another isosceles triangle. And these two angles are equal, and that'll help me get this angle right here that I need. So if I take 180 minus 118, it gets 62. Both of these have to add up to 62, and both of them have to be equal, so they're both 31. 62 divided by 2. All right, so skill 5 is a little bit of a strange inscribed angle. So this is what we're used to seeing. So this is an inscribed angle, and this is its arc. Okay, so the angle is always half of the arc if the angle is inscribed. So if this is 60, this is 30. Okay, so the reason we have to keep this in mind is that any angle that's on the edge of the circle is inscribed. Well, this is what we get if it's tangent. So this is the inscribed angle. It's kind of weird looking. It's not going to be nice how we're used to looking at. It's easy to identify that arc, and then its angle is half. This is an angle we're going to have to be able to work with if that angle is inscribed and it's created with a tangent. So now what you have to see is that the arc will not go out here. It goes from endpoint to endpoint. We're used to seeing it go from endpoint to endpoint. I'm sorry. This angle here, its arc actually goes into the angle. It's kind of weird looking. So let's just try to go through a couple of these. So this is an inscribed angle, and it's on a tangent. It has to be half of its arc. So the arc goes into it. So the blue angle is an inscribed angle. Its arc is in the red, and it's half. So it's 160. The arc is double. All right, another one like this. Okay, so we have an angle, we have a tangent, we have an inscribed angle here, and as well over here on this side is also. Okay, so there's two ways you could do this. A is, notice that this has to be 360, and we have 264 of it. So if we take that 264 arc away from 360, minus 264, I have 96. So this arc here is 96. So that blue inscribed angle, that is its arc, and then all we do is take half of that, and 96 divided by 2 is 48. That's one method. Another method is some people will recognize this, that is actually a half circle. So if I focus on this 264 And this is the angle that goes with that. So that's half. So if I take 264 divided by 2, I get 132. And then apply the half circle, you get 48 again. So these are the 5 skills that you need to have when we're dealing with tangents on circles.